So to refresh your memory, what we were doing last time, we were graphing rational functions.
Oh, I got new pens.
Oh, that's fun. New colors.
Yeah, new colors. We have the same colors. Well, now I got more colors. Than me? No, like I didn't have as many colors.
Okay, that's what I thought. Okay, so we each get an answer.
I posted it, but I posted the recording, but I don't think I transferred it onto Classroom. I think it's in my YouTube channel. Could you go to my YouTube channel? I'm pretty sure I posted it. It'd be Unit 5, Day 1.
Oh yeah, you could choose colors sometimes, now you have to pull.
They're like gel pens though, so like they don't.
Are these gel pens?
But we're doing the same thing today, so you'll pick up on it. Okay, guys. So we want to do a sketch of -4 over x minus 3. There's certain things we have to ask ourselves. The first thing we're looking at is the domain. I already went through this before break, but I will recap. When is the domain affected? The domain is affected when there is a variable in the denominator. So we know the denominator cannot equal 0. We know a radical in the numerator will be greater than or equal to 0. And a radical in the denominator will be greater than 0 because it cannot equal 0. So those are the 4 things that affect the domain. So in this first problem that we're sketching, -4 over x minus 3, there are no radicals. But is there a variable in the denominator? Yeah. So we're going to take that denominator and we're going to say x minus 3 cannot equal 0, which means x cannot equal 3. That is our domain. Our domain is any number except x cannot equal 3. Any number except 3. Okay, next part. We're going to look for vertical asymptotes. Which I write as VA, vertical asymptote. So we're going to have a vertical asymptote. We set the denominator equal to 0. So once again, we're going to take x minus 3, set it equal to 0. So we will have a vertical asymptote at x equals 3. The next one are the zeros of the graph. So for the zeros, we're going to set the numerator equal to 0. But look at our problem. Can we set the numerator equal to 0 here? Is there any variable there? No. So guess what? There are no zeros here. So our graph is not going to cross the x-axis at all. The next one is the horizontal asymptote, which I call HA. And so for the horizontal asymptote, what we're going to do is we're going to take the limit as x approaches plus or minus infinity of our whole function, which is -4 over x minus 3. So we take the limit. Okay, so if you guys remember when we were doing limits, when you're taking the limit, don't you, approaching plus or minus infinity, don't you choose the most influential term on top over the most influential term on the bottom? So this is going to be -4 over x. And what is x approaching? Infinity. So when you have a small number divided by something really big, what's that going to be? Not infinity, no. Something small divided by something really big. 0. Small divided by really big. Small divided by really big approaches 0. So we are going to have a horizontal asymptote at y equals 0. And the very last thing we're going to ask, does it cross HA? Right? Just a special star here, we never cross the vertical asymptote. We never cross a vertical asymptote, but we can cross a horizontal one. So when we want to decide does it cross, what we're going to do is we're going to set function equal to the horizontal asymptote, then solve. So we're going to take our function -4 over x minus 3. We're going to set it equal to our horizontal asymptote. What's our horizontal asymptote? 0. So we set it equal to 0. Now we solve. So I'm going to cross multiply this. And we're going to get -4 is equal to 0 times x minus 3. What's 0 times anything? 0. Does -4 equal 0? No, so that means we do not cross. Now we're ready to start our sketch. Okay, so let's go. All right, so we have a vertical asymptote at x equals 3. So I'm going to go to x equals 3, and I'm going to draw a vertical asymptote. So there's my vertical asymptote. Then I have a horizontal asymptote. What's our next one? Horizontal asymptote at y equals 0. So that's the x-axis, but I'm going to go over it to remind myself that it's there. There are no zeros. And we do not cross the horizontal asymptote. Okay. So now, what we want to do is we use our vertical asymptote sort of as our guide. What we need to do is we need to figure out what's going on to the left of the vertical asymptote and to the right. So you only need to test 2 points here since there's only one vertical asymptote. So now I'm going to pick points to test. And y will equal -4 over x minus 3. I put in our original function. So now I'm going to test a point to the left of our vertical asymptote. If I'm going to test a point to the left of the vertical asymptote, do you think I can let's test 1. Are you guys okay with that? So I'm going to test x equals 1. So what I do is I plug in 1, so -4 over 1 minus 3. And then I simplify it. So I'm -4 over -2. What's -4 divided by -2? +2. So I'm going to have the point 1, +2, which is right over here. I'll let you all catch up. All I need is 1 point because the asymptotes guide what we're doing. So am I going to cross my horizontal asymptote? No. Am I allowed to cross the vertical one? Never. So what's going to happen is I'm going to have to come really close and hug it, and then come really close and hug the vertical one. So it guides it for me because I know I cannot cross it. So now we got what the graph looks like to the left of the vertical asymptote. What do I need to figure out now? What happens to the right of it? So now I need to pick a point to the right. Can I pick 4? Is that okay? Yeah, let's pick 4. So we're going to have y equals -4 over 4 minus 3. So then that's going to be -4 over 1, which is -4. So that means I'm going to be at 4, -4, which is right over here. So now I know which area I'm in. Now it's all about just hugging the asymptotes. Boop, just like that. We ready to try another one? Anybody still copying? No? Okay, let's try another one. So it's not hard, it's just a lot of prep work. So now let's say we have y equals x over x plus 4. So we're going to start off with our domain. How do we find the domain? Good, we set the denominator equal to 0. So we know x plus 4 cannot equal 0, so x cannot equal -4. Then we're going to do our vertical asymptote. So once again, the vertical asymptote denominator we set the denominator equal to 0. So x plus 4 equals 0, x will equal -4. So we will have a vertical asymptote. Are we allowed to cross the vertical asymptote? Never. So we did domain, we did vertical asymptote. Now I'm going to ask for the 0. How do we find the zeros? Good, we set the numerator equal to 0, so we set x equal to 0, which is just that. So is there a 0 here? Absolutely. So we did domain, we did vertical asymptote, we did zeros. Now it's going to be the horizontal asymptote. How do we find the horizontal asymptote? The limit. We're going to take the limit as x approaches what? Yep, plus or minus infinity. Now we do of the whole function. But now you need to remember, whenever you're taking the limit to infinity, as it approaches infinity, we simplify it down. Most influential on top, which is x, over most influential on the bottom, which is x. But what's x divided by x? 1. So that means we will have a horizontal asymptote at y equals 1. The last thing we ask ourselves, does it cross? Can you cross a vertical asymptote? Never. So what do we check for it to cross? The horizontal. Who remembers, how do we check to see if it crosses the horizontal asymptote? Good. We're going to set the function x over x plus 4 equal to the horizontal asymptote, which in this scenario is 1. Last problem, what was the horizontal asymptote? 0. So now we cross multiply, and we're going to get x is equal to x plus 4. But then the x's cancel, and I get 0 equals 4. Is that a true statement? No. So are we going to cross? No. Are we ready to sketch? Okay. Okay, so here we have our vertical asymptote at -4. And we have a horizontal asymptote at y equals 1. But we have one more thing to plot here that we didn't have before. What else do we have this time? We have a 0. So that means we're going to cross the x-axis at 0. This is nice, having that 0. Why is this nice? Because we need to figure out what's going on to the left of the vertical asymptote and to the right. This 0 already tells us what's going on at the right. Why? How? So because I'm below the horizontal asymptote, I know that I'm not crossing it, so I'm staying below it, which means I have to hug it this way. And then what should I do? What else should I do to get the rest of the graph? Go down this way. Because we have to get close to the asymptotes but never cross them. So as long as we know sort of which quadrant we're in, we could always create that sketch. But do we know what's going on to the left of that vertical asymptote? No. How do I figure out what's going on to the left of the vertical asymptote? What should I do? Test a point. Yep. So this is our test. So we had a vertical asymptote at x equals -4, so I will just go with -5. So y will equal -5 over -5 plus 4. So this is going to be -5 over -1, which gives us a +5. So now I go to my graph, and I'm going to go to 5, +5, 1, 2, 3, 4, 5. So now how should I fill in the rest of the sketch, knowing that that's where 1 point is? We're going to go down and left, just like that. Do you guys want to try one on your own now? Why no? Here you go. You guys try this one. So I want you to find the domain, the vertical asymptote, the zeros, the horizontal asymptote, and if it crosses. So you guys do this, and then sketch, and we'll go over it. Are we ready to go over it? Who wants more time? Anybody need help? I'm helping you. Let me see. Oh, I hope this wasn't a cross one. Was this a cross one? No, I didn't get that across. When you subtract the x, right, it cancels. Minus x will cancel. So then it doesn't cross.
Set function. You set the function to this one, but I don't know this one, so I can't do this one.
So you're going to have a 0 and x is -3. So this is the problem. So your horizontal asymptote, nope, this is 1, but it's not x over x, it's x over negative x, which makes this negative 1. This would be -1, which then means it won't cross. Oh. Okay guys, let's start going over this. So here we have the domain. Remember, for our domain, it's affected by 3 different things: a variable in the denominator, a radical in the numerator, or a radical in the denominator. Those are the 3 things that affect our domain. In this one, we only have a variable in the denominator, so we know 1 minus x cannot equal 0. So then we know x cannot equal 1. So our vertical asymptote is also when our denominator is equal to 0, so we will have a vertical asymptote at x equals 1. Our 0 will be when our numerator equals 0, so x plus 3 will equal 0 when x is -3. And then the horizontal asymptote is going to be the limit as x approaches plus and minus infinity. And now you take the most influential on top, which is an x, but the most influential on the bottom is not a positive x, it is a negative x. So you take the coefficient with it. So this ends up becoming -1. So we will have a horizontal asymptote at y equals -1. How many people got all of those? How many people got all of that except the horizontal asymptote? Okay, do you understand the mistake now? We want the coefficient with it. So now we're going to ask ourselves, does it cross? So the way you figure that out is you take your original function, which is x plus 3 over 1 minus x, and set it equal to the horizontal asymptote, which is negative 1. When you cross multiply this, you're going to get negative 1 times the quantity of 1 minus x equals x plus 3. You need to distribute in that negative 1. So this is negative 1 plus x equals x plus 3. And when you subtract the x, they both cancel, so negative 1 does not equal 3, so this does not cross. So now we are ready to sketch. Okay, so now we have a vertical asymptote at x equals 1. And we have a horizontal asymptote at y equals negative 1. We do have a 0 at x equals 1. Oh, that's wrong. How do we have a 0 at x equals 1? Oh, negative 3, sorry. X equals negative 3, here we go. So because we have that 0, do we know how the graph on the left looks? We should know how the graph on the left looks. So we're going to hug the horizontal asymptote that way, and then what should I do? Go to the vertical asymptote and hug it that way. So now we need to figure out, so we know what's going on to the left of the vertical asymptote, we need to figure out what's going on to the right. So we have to test the point. So our vertical asymptote was at 1, so I'm going to go to 2. So y equals 2 plus 3 over 1 minus 2. 2 plus 3 is 5, 1 minus 2 is negative 1, so this gives us negative 5. So then we're going to go to 2, 1, 2, and then 1, 2, 3, 4, 5. Should we know how the graph looks now? Yep, we hug the horizontal, turn it, hug the vertical. And this is just a general idea of how it looks. How many people were able to do that? I plugged in 2. All right, we'll stop here.